Okay, in this video we'll continue the previous problem in example 6, and that is the elevation of the submersible now is modeled by the equation h of t is equal to 500t minus 10,000 feet. We want to graph the function, identify its domain and range, interpret the slopes and the intercepts of the graph. So you recall that for our purposes, h of t is simply another way of saying y is equal to 500x minus 10,000. So h is a function, which means that the height below the surface of the water at any time t can be determined by plugging in the value of time, how many minutes after the submersible begins its ascension from the floor of the ocean to the surface of the ocean. So two things that we would want to do here to graph this, and one is to find its intercepts. Even though this is in y equals mx plus b form and not in standard form ax plus by equals c, we can use this form to still find out what the intercepts are. And so what we're going to do is let x or t equal 0 in this case. When you can see that when x is equal to 0, we get y is equal to negative 10,000. And again, y and h of t, they really mean the same thing in this case. So we're going to start off at 10,000 feet below. Now, that we can do two things in this case. Since we know that the slope is 500, what that means is that for every minute the submersible is rising 500 feet. And since our graph is already graphed in thousands, it wouldn't be after 1 minute, but after 2 minutes we will reach 1,000 feet. So according to our graph, then every 2 minutes of time we will increase 1,000 feet, since we're going 500 feet per minute. And so if I were to continue to graph at that rate, notice that all of those points are falling on a straight line, and eventually we are going to hit 20 seconds again. So if the submersible started out at 10,000 feet below the surface of the water, and if it was rising at a rate of 500 feet per minute, then in 20 minutes it would reach the surface of the water. Now we could also determine this algebraically by letting y, that is the height, equal 0 and solving for x, or solving for t. And we would add 10,000 to both sides. And we would get 10,000 is equal to 500x, dividing both sides by 500. We would get 1,000 divided by 5, so x is equal to 20, and that would be 20 minutes here. So that can show you also that at time t equals 20, the submersible will reach the surface of the water. So we would just simply draw in a line connecting all of those points there, and there we have it. Now, two things we wanted to do. We wanted to graph the function, which we did. So we did this a slightly different way this time. It was much easier because the slope was 500. In the previous problem, the slope was 650, and it really wasn't easy to find points that were right on at the intersections on the grid that we could easily plot. Now once again, let's talk about the domain and the range. The domain is the set of all possible input values. Those are the x values or the t values. So the domain here is going to be from t is equal to 0 to t is equal to 20. The range is the set of all possible y values. So that will go from negative 10,000 up to 0. So that is the domain and the range. They both tell us something. Now we're going to interpret the slope. M equals 500 feet per minute means the submersible is rising at 500 feet per minute. That's how we interpret that. And then finally interpret the intercepts. Once again, x-intercept means that the submersible reaches the surface at t equals 20 minutes. The y-intercept means that the submersible starts at 10,000 feet below the water surface. And so once again, the x and the y-intercept, the slope, the domain, the range, the function definition all mean something in the context of this problem. And so these are examples of functions that we will be working with again throughout the course of this class. We'll stop this video.